What's up, everybody? Welcome to CS2304 again. And this lecture, we're going to be talking about something that I'm going to call pod managers. Okay, there's not a specific term to use for these, but we're going to be talking about things that can help automate the deployment and scheduling and when we run pods and how they run and kind of rollouts and a bunch of different things. So here's our overview for today. Okay, so we're going to talk about just a quick recap of the pod spec review. A review of the pod spec, and then we're going to talk about lots of different objects that can use the pod specification to deploy pods in a variety of different ways, and we'll talk about those different ways throughout this lecture. So we'll talk about replica sets, what they are, how we use them. Same thing with deployment sets, DaemonSets, jobs, and CronJobs, and then we'll kind of just recap at the end to talk about when you use which one. Okay, so let's start off with our pod spec review. Okay, so the pod specification up to this point, we've talked about lots of different ways to define pods, but again, the way to think about a pod is just it's a request to run a compute workload of some sort. Okay, so to run a container image to do something, whether it's running a web application or to run a little verifier that verifies or runs tests, or there's so many different things that containers can do. But a pod at the end of the day is just a schedulable unit of work, okay? And as part of that specification, we've talked about how do we create the container, what images do we use, how do we create the volume mounts, how do we populate those volumes, environment variables, etc. But there's a lot of other things that we haven't talked about, and we will still here in the future. For example, scheduling info and affinities. I may say I want this pod to only run on nodes that have a GPU or on Windows machines or whatever. Using scheduling and affinities, node selectors, etc., we can determine where our pods should be able to run. And init containers are a way for us to say before you actually start the main container, run some kind of startup processes that may, maybe you can use that to populate a volume. And we actually do some of this to say, go, start an init container that will go and fetch secrets from a place and put it into a volume that's now shared with the container. So rather than populating a volume from a config map or secret, we're now populating it with something else. There's a lot of other use cases for init containers as well. We may also configure the pod's DNS or other network config. And there's just so much more we can do. If you want to dive into it, you can actually look at the pod API, which we hinted at during the first week of actually getting into Kubernetes. And you can see all the things that you can define on in the pod specification. Okay? But the whole point of kind of doing this review is that many other objects can kind of consume the specification for a pod and use that as part of their specification. And so consume isn't maybe necessarily the right word, but it's more of embedding what the definition for a pod within the specification of another object. Okay, and those other objects can automate the deployment in a variety of different ways, which we'll see. Okay, so the first one that we're going to talk about are the replica sets. With replica sets, it allows us to define a desired number of replicas for a pod. And by replica, I mean how many instances of the pod. Now, this would be incredibly helpful for applications that may get a lot of requests, or I want to run highly available. I may want to say I always want 2 instances of this app running. And so replica sets let me do that. There's a controller that's running as part of Kubernetes that's basically watching the current cluster state. And when I define the replica set, it says, okay, I know your desired state. Now let me watch the cluster state and as part of a feedback loop, reconcile state. So if you say you want 2 instances of this running and there's 0 that are running right now, well, let me fix that and let me launch 2. If one of them dies for some reason, let me spin another one up, and we'll see some examples of that here in just a minute. Okay, so again, there's this. Again, think of Kubernetes as I'm just declaring my desired state, and then there are components, controllers, as part of a feedback loop that are constantly evaluating, is the desired state satisfied right now? Okay. So how do I define a replica set? Well, I just, again, define the state, and here's what that looks like. I specify the kind of replica set. The API version is now apps v1, so just remember that's a different API version. Metadata is the same as all the other objects that we've worked with so far, the pods and services, etc. I can define a name and labels. Now the spec looks a little different because now we're providing the specification for a replica set. And in the replica set, I can specify the number of replicas that I want to run, in this case 3. Then I also provide a selector and say, this replica set is going to manage all pods that match this label. And we'll try out some various scenarios here as well. But now when a replica set determines that it needs to launch a pod, well, the way that it does that, it uses the template. And it basically, here's a pod document right here. So the metadata, the labels need to kind of match here. I can have additional labels here as well, but I need to at least have the ones that are going to be matched. And then I have the specification to go from there. Now, one of the things to note here, and I've got this last bullet here, is that the template doesn't have the name because the replica set will generate a name for the pod. Okay, so let's actually try this out now. In my terminal here, I've got a ReplicaSet file here, and let me just revert this back here. And it's the same as what we have in the slides. So let's go ahead and deploy this. And what this is going to do is it's going to define the replica set, and immediately I can say get the replica sets, and the CLI will say, all right, here's the replica sets. You said you wanted 3. There are currently 3, and all 3 are ready. Cool. And so now if I ask for the pods, I see that I have 3 pods running. Let's go ahead and nuke one of these and see what happens. And what we'll see is one is terminating, but again, that feedback loop is already playing, and the controller sees, hey, you wanted 3, one of them's terminating. Let me go ahead and spin up a third one so that you've always got 3 running. Okay, and so it's going to make sure that's the case, and it even works if I try to let's be really mean here and try to nuke all 3. Okay, and now what we'll see is, well, again, it's going to say, hey, you're expecting 3. There's 3 that are terminating. I'm going to spin up 3. So again, the replica set ensures that you always have the intended number of replicas running. Now, so one thing that I'm going to do here is I'm actually going to spin up another pod that has the same labels that the replica set is matching. Okay, and we'll see what happens here. When I do this, we'll see that it got created, but it's immediately being terminated. And that's because, well, the labels match what the replica set was looking for. And it said, hey, this is another pod that has these same labels. I'm already at my desired 3 instances right now. And so there's one too many here. And so I'm going to nuke it and get rid of it. So that's something to be aware of. If we really didn't want that to happen, what I could do is let's look at one of these pods that the replica set did spin up. In the metadata, it's used in another field called owner references that basically says, hey, this pod is being owned, is being managed by this replica set. So if I wanted to spin up a pod that's of my own, a manual pod that I'm defining here, even if the labels match, I could specify my own little owner reference here, and then the replica set will say, this thing's already being managed, it's already being owned by something else. I'm going to ignore it for now. Okay, so just a heads up that's there. Last demo here, if I now change the replica count to 5, if I can actually type it, 5, what we'll see is, as expected, it's going to spin up 2 more containers, and I can do the same thing now to spin this down. I can even spin it down to 0 if I want. And if I do that, now we'll see it, all of them get terminated. Okay, sad day. And finally, let's get at least one here. Okay, so we've got one that's creating. One thing to note is if I delete the replica set, it will also delete all the pods that are being managed by that replica set. Okay, so again, it makes cleanup really easy. If I just clean up the replica sets, it'll clean up all the things that it's owning and it's taking care of as well. Okay, so replica sets are great, but for the most part, you'll never actually interact with them directly, and that's where deployments come in. Okay, so deployments are used to automate the rolling out of new pods, and kind of jump into the last bullet point. It removes the, hey, you can't update that field on the pod errors. And I know many people have run into this with the hands-on and whatnot, that they're trying to define an environment variable or add an environment variable or change something about a pod. They apply the pod and it says, boom, you can't do that. And so you have to delete the pod and restart the pod. Well, deployments manage that, because what they do is you define the deployment and you can make changes to the deployment. And what it will do is it will spin up a new replica set that has the new metadata in it and manage the scaling. Okay, so whenever I make a change to a deployment, we'll see this here in just a minute. What it will do is it will create a new replica set, and let's imagine that I had a version 1 of my app running and I had 3 replicas. When I deploy version 2 of my app, it'll initially have 0 replicas for that new replica set, and then work on scaling the old one down. So it'll scale this one to 2, the other one to 1. And it works on that kind of migrating from the old replica set to the new one to reduce downtime of your application. Okay. And what's cool is it still keeps the old replica set just scaled to 0. So now if I want to roll back to a previous version, all it is scale down the current one and scale up the old one. And so it makes rollbacks really, really easy to do. And you'll try that with the hands-on this week. So defining deployments, it looks very similar to ReplicaSet. The only thing that's changed is the kind is deployment, and there are additional properties that we can define. So the spec still has the replicas. And we can also define what's called a rollout strategy. And the rollout strategy is how that scaling between replica sets works. So by default, it does that rolling update where it scales the old one down and the new one up. But there's also another strategy that's called recreate, where basically says, hey, nuke everything and then bring up the new thing. And a use case for that might be version 2 of my app, when it launches, is going to run database migrations that completely change my table schema that the old one wouldn't be able to query against. And so it doesn't make sense. And maybe I don't want to have the old one running at the same time because it might cause errors, whatever. And so I just want to simply tear down everything and then spin it up. But again, that's a choice you can make. There's also a couple different properties. I won't go too much into this, but you can configure the rollouts by specifying a max surge and max unavailable, so you can kind of choose how it does the rollout. So in this case, I've got a deployment that will run 3 replicas, and as part of the rolling update, I'm going to allow it to surge up to 100%. So that means that this could technically be running 6 instances of this deployment, granted 3 old, 3 new. And so I'm going to let it surge to a greater number and then kind of scale down the old. And again, you can use these properties to kind of control how the deployments roll out new updates. Okay, so let's do a little bit of demo here. So I've got a deployment here, and this is going to deploy my CATS application that I've demoed a couple times, and version 3.0 is actually Whales. Whale GIFs, if you want to take a look at it. So let's go and deploy it. We see the deployment got created. I can look at my deployments, and okay, I've got 3 out of 3 are ready. And again, if I look at the replica sets, I can see that I've got a replica set. And finally, let's look at the pods. Cool. Now let's go to my deployment and let's revert back to dogs. Okay, so I'm going to deploy version 2.0. Okay, so it says it's got it configured. If I look at the deployments, I see, okay, 3 out of 3. So 2 of them are up to date, which means that one of them hasn't finished deploying. Cool. If I look at my replica sets, now what I'll see is I've got 2 different replica sets. One that's scaled to 0, that's my older one, the 48 seconds, and the new one that's at 3. And I'll do another deployment here in just a second, and we can actually watch the update. Okay. And if I look at pods, obviously I'll see the old ones are still terminating. Maybe they're just taking a little long to actually get nuked for some reason. And I've got the 3 new ones starting. So let's do one more deployment here where I'm going to go to version 1.0 of my app. And let's go split screen here. And I don't know why it put me in a temp directory, but whatever. Get ReplicaSets, and I'm going to watch the changes here. So we'll see that there's a new one got created, and it may be a little hard to see the numbers just because of how the events are showing up here. But we can see that it's kind of scaling one up and scaling the other one down and rolling out my update. Now, again, this is happening really, really quickly because of just this application. And one of the things I'm not doing with this deployment is I'm not defining any probes. So if you remember the readiness and liveness probes that we talked about in the past, if I define a readiness probe, it will use that as part of the deployment. So it'll start up a new pod and wait for it to actually be ready before it starts the next step of the rollout. So that's yet another reason for you to think about using probes, because it helps out with that process. All right, let's go ahead and delete my deployment. And just like with the replica set, when I delete the deployment, it'll delete the replica sets, which will also delete the pods. And I will see that it's nuking them all. Cool. Back to slides. So again, deployments are pretty powerful, and you'll use them quite a bit. DaemonSets. So DaemonSets are, again, another way to schedule pods, in which, in this case, what it's going to do is it's going to run one instance of a pod on all nodes in the cluster. So I'm not going to give it a specific number of replicas, because the number of replicas are going to equal the number of nodes, and it's going to schedule one on every node in the cluster. So the use cases, there are many. Might be, I'm going to run a metrics server to collect metrics from every node. So maybe I want to see CPU and memory utilization both from the node as well as pods that are running on the nodes. In order to do that, I need to run a little agent on each of those machines that can kind of collect that information and send it back centrally. I might want to run a log collection service, and this is something we do here in our clusters here on campus, that every time a node starts up, we run a little agent that collects all the logs from the pods and then sends those logs to our central logging service. And then finally, we want to run a cluster storage service on our nodes. So for example, if we want to use EFS or EBS, since we're using AWS, how do we provide those storage options to the containers? And in order for a container to use an EFS mount, for example, that EFS needs to be attached to the node, and a DaemonSet little agent can help make that work. Defining a DaemonSet looks just like the deployments or replica sets that we saw, just the only difference is now we're not specifying replicas, because that's going to be based on the number of nodes that the pod may be working on. So in this example, we're not actually going to deploy anything, because locally on Docker desktop, I only have a single node, but I will show off just a little bit of our cluster environment here. So in this case, I'm switching my context to use different credentials and point to a different Kubernetes API rather than my local machine. It's now pointing to our platform environment. And I'm looking at a specific namespace that's called platform filebeat, which is where our log collectors are running. So if I ask for the DaemonSet, it's expecting there to be 9, and I see 9 different pods running across the cluster. In fact, let's run this again, and let me add the wide flag on there, and it will tell me the different nodes that they're running on. And so we see that there's no duplicates there, and they've been running for quite a while. And if I look at my nodes, I actually see 10 nodes here, but that's because one of these is a spot instance that's running CI builds, and we don't run our log collection service on our CI build nodes, because the CI agent is already sending those logs back to GitLab for us. So we don't need to run that ourselves. So again, this DaemonSet, as we need to add or remove capacity to the cluster, as we add nodes, it will automatically run this log collection service for us. and send our logs to the central logging service and satisfying all the IT policies and all that stuff. And we never have to think about it again, which is pretty slick. So finally, jobs and cron jobs. Jobs are a way for us to run a pod, and it will keep retrying until it successfully completes. And cron jobs then let us schedule those jobs. And so use cases might be, and this is a pretty valid one that we use quite a bit. Whenever we pull containers from ECR, which is AWS's container registry, the credential that you use to pull from ECR is only valid for like 8 or 10 hours or something like that. So it means that you constantly need to refresh that credential. Well, we don't want a person to have to manually do that. So we create a cron job that says every 6 hours, rotate that credential. And that means there's always a fresh credential ready for us. Other use cases might be running nightly jobs such as backups or maybe some sort of garbage collection or creating summary email notifications or whatever it is. We can specify these jobs and cron jobs to run on a schedule. There are some caveats, which I'll talk about in just a minute on the scheduling of that. Defining a job looks, again, just like the other objects, but now we don't need a selector because it's not going to, watch multiple replicas or anything. We're just simply saying, hey, here's a template, run this pod, and keep going. You do have to set the restart policy in the pod to never, which means if this container dies, don't restart it as part of the pod, but the job itself will restart it until it reaches the back-off limit. The back-off limit defaults to 6, and so if the job fails 6 times, it's not going to run a 7th time, and it just says, hey, this job failed. And then you can kind of watch for that and inspect it and kind of find out what's going on, whatever. But it won't just keep running forever. It'll go to that back-off limit. And then cron jobs lets you run jobs on a schedule. And it uses the cron syntax. If you ever use cron on a Linux-based system, it uses the exact same syntax. So 5 spaces here, one for the minute, hour, day of month, and then day of the week. So you could say, I want to run this job every Sunday at 3 a.m. In November or whatever. You can get pretty creative with the schedule that you want. This particular one is going to run the */1 means, okay, every minute that's divisible by 1, which is the same thing as just star. But you can say, I want to run this every 15 minutes. So */15, and it'll run every 15 minutes. So this is going to run every minute, this particular job, and do something. So let's actually do a quick little demo before I jump to the recap. And I've got a cron job here. That's what it's going to do is basically the same as what we have on the slide. I just gave it a command. That what the command is going to do is just echo the current date. Okay. And this is going to take a minute for it to run because the current time is 12 seconds. And so while it's doing this, I'll talk about the caveats here. So with crons, Kubernetes is going to say, yeah, go ahead and schedule this, and great. But it doesn't necessarily mean that it's going to run at exactly the moment in time that you schedule it. Because, well, think about it, there's lots of things that have to happen. The container image has to be pulled, has to be started, and depending on how large that container is, that may take a minute or two. That's also assuming you've got capacity in the cluster. I talked about our platform cluster. If we need capacity, it's going to add another machine. Well, it takes time to spin up a machine. So just depending on lots of different things going on, your job may not run at exactly the point in time that you schedule it, but that's going to be when Kubernetes schedules it, and it will be a best effort, hopefully try to spin it up as quickly as it can. Okay. All right, so let's look at my cron job. So the last schedule was 22 seconds ago. And if I look at the jobs, I should see a job here. And if I look at the pods, I should see that a pod did complete. And if I look at that pod, I get the date. And you'll notice that the date wasn't directly on the minute. It was about 2 seconds after. And probably as I was talking, it probably already ran the next job. Nope, it'll still be about 15 seconds here. And so this will about another 10 seconds. So we'll see another job get scheduled. and then it'll take another second or two to actually start up the container and do the log. So yeah, even that took about 2 seconds. And so let's look at the logs for this one. And so yeah, about 2 seconds. So again, Kubernetes is going to schedule the cron job when you told it to, but it doesn't necessarily mean that's going to be exactly when it executes. So that's just something to remember. So as a quick recap, I know I talked about a lot of different objects and everything. When are we going to use what? For the most part, deployments are going to be what you use whenever you want to define an application or a service or anything of that sort. Because again, it manages the rollout, but also makes it easy for you to make changes to the pod, add environment variables, or change your volume, or whatever, and it manages the rollout for you. Okay? So again, deployments are typically going to be what you use. DaemonSets are going to be in the kind of the specific use case where you have something that you want to run on every node in the cluster. Jobs and CronJobs allow you to kind of run one-off tasks, and the CronJobs let you schedule those tasks. And then the ReplicaSets, again, are there, but for the most part aren't going to be something you directly interact with. It's going to be something that the deployments are going to automate and leverage. At the end of the day, if you want to manage a ReplicaSet directly, you're welcome to do so. There's nothing stopping you from doing that, but in normal use cases, you won't, but it's just good to know that it's there. Okay. And this week's hands-on, we're just going to be practicing all the various types and getting familiar with them, and more or less doing a lot of what I just did in the demos of defining something and tearing it down and seeing how it works and that kind of stuff too. So as always, if you've got questions, feel free to reach out and let me know. And hope you have a good time with the hands-on, and we'll go from there. So thanks for tuning in, and I will chat with you later.